Projectile motion is the motion of an object under the influence of a uniform field. And now this could be a gravitational field or an electric field, something which is only ever forcing that object in one direction and with the same size of force. Now, before we start talking about projectile motion in detail, I want to remind you of a couple of things. The first thing is that vectors, which are things like force and velocity, can be separated into different components. So we could separate a vector such as I've drawn over here in this little diagram. So this is a velocity vector. I could separate it into horizontal and vertical components. The second thing that's important to remember is that those components, if they're perpendicular to each other, can be treated and calculated completely separately. They can be treated as completely independent of each other. I'm going to show you a little video clip which demonstrates this really beautifully, using a ball which is dropped from a height and also is projected to the side from the same height. In the vertical direction, both balls are under the influence of gravity, so they are falling vertically at the same rate. The one on the right is also travelling horizontally at a constant speed. Horizontal motion does not affect the vertical motion. So I hope that convinced you in some way that those components can be treated independently of each other. The third thing I want to talk to you about before we get into an example calculation is that in projectile motion, for example, we're going to stick with the example of gravity, but we can use the same ideas in other situations. That, for example, in gravity, the vertical motion is under the influence of gravity, so it has an acceleration which is due to gravity, which is 9.8. But the horizontal direction, that motion doesn't have any forces acting on it. There's no, once something has left the hand of the thrower or has been fired by a cannon, after it's left that object which is applying the initial force, there is no other force acting on it, as long as we assume air resistance is negligible. Now, I've just noted there that it's on the Earth's surface. So the vertical acceleration is 9.8 meters per second, and I've defined it as negative because I'm defining the direction down as being negative and up as being positive. The fourth and final point before we get on to this calculation is that we can treat these vertical and horizontal motion independently, but the time taken for the horizontal motion is obviously the same as the time taken for the vertical motion. So if we're talking about something that's being thrown up in the air and measuring how long it takes to go down, that will be the same as if it were going up in the air and a horizontal distance and dropping to the ground some distance away. I'm a bit worried that I'm going to run out of space here, so I'm just going to shrink that text down a little bit. Okay, here goes our example, which is the best way to talk about projectile motion. I'm going to label this as u. This is our initial velocity, our initial speed. And I'm going to say that u is 100 meters per second, because that is easy. If after that thing was projected, say from a cannon from ground height, it would follow kind of a parabolic path and back down to the other side there. Let's say, for the sake of the argument here, even though it doesn't look like it, that this is 25 degrees. Now I can use my special tricks of finding the components of vectors by saying that is 100. I can work out, and that's 25 degrees, I can work out the size of the vertical and horizontal components of that motion. So I can say uv here is 100 sine of 25, and the horizontal UH is 100 cos of 25 degrees, and I'll write them down below. What I'm going to do first of all is divide my page into two. I'm just going to see what I can calculate, as many things as I can. And I'm going to label this over here as horizontal motion and this as vertical motion. And let's see what we can come up with. Okay, I'm going to write down that calculation again for the horizontal speed, the speed in the horizontal direction. 90.6, and I'm going to do the same for the vertical direction. I'm also going to write down any other information that I know. So I know that the acceleration is negative 9.8 meters per second because I've defined the vertical direction going down as being negative. I also know over here that the horizontal acceleration is 0, and I also know that the final velocity in the horizontal direction equals the initial velocity in the horizontal direction, and that's because there are no forces acting in the horizontal direction, so the speed cannot change. Okay, I might like to find out the height of the path. And I know that at the top of the path, the speed, the vertical speed, the final speed at the top is 0 meters per second. It essentially comes to a stop and then it turns around and comes back down again. So I can look at what my equations of motion, and I can find the v squared equals u squared plus 2as. That's just one of those kinematic equations. I have the final vertical velocity, the initial vertical velocity, I have the acceleration, and I would like to find the displacement. So I'll just quickly rearrange that and substitute in, we get 91.3 meters. So that is the height of the motion. I'm going to continue on here with some more vertical stuff. I'm going to find the time in the air. I'm going to use this equation and make it just for my vertical motion. So that is negative 42.3 meters per second for that vertical velocity at the end, so when it's falling back to the ground, it's reached the ground. So if I just rearrange this equation, I can work out the time in the air and work it out to be 8.6 seconds. I know that if it took 8.6 seconds to go up and then go down, it's going to take 8.6 seconds to travel sideways as well. So the time for the horizontal motion is also 8.6 seconds. And I could use this kinematic equation, S equals u t plus 1/2 a t squared. These are all in the horizontal direction. I know that my horizontal motion has a 0 acceleration, so that whole term drops out. So I can just plug in what I have for my initial horizontal velocity and the time, and I get a final answer of 782 meters. So there you go. I calculated some stuff about that motion just by knowing that I could separate the horizontal and vertical motion and treat them completely independent of each other. I could have done it in a different way, no doubt. There are different, I could have chosen a different equation and used different values to find things in a different order. So there's no right way or wrong way to approach a projectile motion problem. I suggest just going through and calculating what you don't have and seeing where you end up.